All right. Hey, so first of all, thanks everyone for joining on Thursday evening in May. Uh, my name's Robert Yee. I'm a senior systems engineering manager here at Cisco. I run the data center networking team for the West. Just recently moved into that role. And also on the call is Jason Bomar. We've been doing this group for 21 years, Jason, is that right?
Coming up on 22. We're going to be 22 in July.
Yeah.
Wow. We should have celebrated with drinks.
Yeah. Don't start aging yourselves.
That's right. Yeah, for sure. Charlie's been with us for almost the whole time, huh?
Pretty close.
Yeah, pretty close. Sorry, I totally went off a tangent. But anyways, we're not here to talk about myself or Jason or the user group. We'll get to that. But we are here to talk about next-gen firewall. And we do have a very special guest, Mark Kasper. Mark is a solutions architect with our security team. I'll let him do the proper introduction, but I've known Mark for a very long time, as long as I've been at Cisco, and he's just an amazing resource for everyone here at Cisco here in the West. So Mark, with that, I'm going to hand it over to you, and it is your show.
Thanks, Robert. I'll send you your check later. Yeah, Mark Kasper, been with Cisco for, going on 14 years now. Started out as an SE. In the field, an account SE, and then moved on to being a CSE, which is an SE but focused on just one product. And now I'm a multi-domain architect for security for the West. So basically it means I'm good at making up answers and making it sound good. That's all that really means. But today, I was hoping we could just kind of have a discussion about firepower, where it's going. Maybe talk about some tips and tricks and things of that nature along the way. I have some content prepared, but I'd like to hear what you guys are using firepower for or want to use firepower for, what questions you might have. So let's start there if that's okay, Robert.
Yeah, absolutely. I mean, if there are firepower users here right now, and if you guys have any questions, I'd say go ahead and Charlie.
Well, I'm not a firepower user at the moment, but in my previous position, Jason actually helped us bring firepower into Regal Medical. And there were some interesting challenges at that point in time. That was a few years ago, so I'm imagining that things have evolved since then. but because it was kind of weird, because you had effectively an ASA, and then if you felt like it, you could redirect traffic off to this other part of things, and it went into a whole different space, and then it jumped back out and came over to you. There were a number of areas where that got kind of confusing, because you could do certain things on the ASA or on the within the firepower module. It really where oddly enough life might be a little bit easier if you don't get those choices. I'm interested in knowing where the product's gone in the 3 years that I have not been using it.
I like how you put that, Charlie. If you felt like it, you could. Yeah, that's good. Okay, so I can cover a little bit of history and where we've gone to there. That's a good talking point. So we'll make sure to cover that. Anybody else? Anyone else using firepower? Used it in the past? Have questions on it? I like uncomfortable silences. Go ahead.
Sorry, I'm not a network person. I'm a security person, and we're using, I don't remember the version yet, but the latest firepower right now, where you log in and you see the building from way up high. You see all these buildings from way up high, whatever version that is. I'm sorry, but I use it daily just to look at intrusion events and packets and all that stuff.
Oh, good. Okay, great. I'm glad to hear that. That's one of the original use cases for it, so that's good to hear.
Good.
Anybody else? I was gonna say I'm okay with uncomfortable silences because I got 4 kids, so any quiet is good. Any quiet is good.
Nice.
Okay, so let's start off with Charlie's topic here, where we can do a little bit of a discussion about how the product evolved and where we're going. And I don't have any PowerPoints teed up. I know you're hoping to see PowerPoints today. I know you were. I don't have any. Sorry, have to deal with it. So I'm on this document here that talks about how firepower passes packets through the box, right? I can put this link in the chat if you like, Robert. Let's do that here. There we go. And essentially, what I want to direct your attention towards is this guy right here. Everybody seeing this okay?
Yep.
Okay. So the green stuff that they have called Lena is the ASA, the old school ASA code. Not ASA hardware, ASA code. Cisco marketing did a great job of confusing everybody by giving the ASA hardware and the ASA code the same name. Then they did the exact same thing with firepower. And so now it becomes a little bit confusing because upon the acquisition of Sourcefire, which is where firepower came from, we had the ASA hardware running ASA code and everything was fine. Then we bought Sourcefire, and 6 months later, we integrated the Sourcefire firewall into the ASA platform. And basically, the ASA platform had this little VM that you could turn on. It was a piece of hardware dedicated for virtualization, and you could install pretty much anything you wanted on there. It was CX, if anybody remembers that monstrosity. It was the old school Cisco IPS. We repurposed it because it's just an x86 CPU to run the Sourcefire code. So now we were running on ASA hardware, we were running ASA code and firepower code on the same hardware platform. And that's what I'm depicting here. The green box is the ASA logical engine, and then the snort engine is the firepower engine. Okay? So the way it would work is the ASA would handle routing and the switching and the state of a connection, right? L3 and L4 firewalling. And then it would hand it off to the snort engine that did all the cool layer 7 application visibility next-gen firewall stuff. And then it would hand it back to the ASA engine because that's the thing that was handling the routing and the packet flow in the first place, to then be sent out the box if snort allowed it to go out. Does that make sense? Any questions?
Sounds familiar.
All right. So that was how it was 6 months after the acquisition. Since then, we've merged the code, right? The ASA code and the firepower code are now a single image, right? And and these things are no longer separate engines; they're just separate processes, just like in a computer, right? You had all these separate processes now just working together to analyze a single packet flow through the box. Okay? Now, the advantage of that is it's all now managed through the Firepower Management Center, right? Before, with this old model, you had to manage the green thing with the ASA CLI or ASDM or CSM, and then you had to manage the blue thing with Firepower Management Center, right? Now everything is just Firepower. Okay, it makes it really easy. Now, I still have the option with the newer hardware. So we now our secure firewalls. The Cisco Secure Firewall is the name of the new appliances that we sell for firewalling. It's Cisco Secure Firewalls. That's just what it is. It can run either ASA code or the new merged code, which we call FTD, or Firepower Threat Defense. Okay? But this idea of two codes running simultaneously on the box, it doesn't happen anymore. That makes sense? We all clear on that?
Sounds good to me.
So management got a lot easier. All the show commands are still available on the CLI of the FTD boxes themselves. But to do any kind of configuration, it's got to be done through the FMC or through the on-box web GUI, if that makes sense. Okay, so let's actually talk about the packet flow then real fast. These are all the little engines and decision trees that go through the box when packet traverses the system. We still have two categories of the Snort instance doing the next-gen firewall, housing the next-gen firewall engines, and we have the Lena instance handling the other engines. Okay, so we still have a delineation there, but we're not handing packets off to see if I can zoom in on this a little bit better. There we go. We're not handing packets off between engines. It's all still looking at the same memory space, and the engine just goes in and does its job, one after the other. Okay? So the first thing we get, packet comes in, is it an existing connection or not? If it's a brand new packet, then obviously no, and that's where we unnat it, and we do the pre-filter policy. Now, who's familiar with the pre-filter policy? Well, let me do this. How many of you understand the idea of policies inside of Firepower? What can someone give me a good idea of what a policy is inside Firepower? Bueller?
I'm not sure. Yeah, I'm not sure if I can go back to that.
Mo, Robert, any ideas?
I remember we had to set them up.
Yeah. So inside of Firepower, you'll have so I'm running FMC or Firepower version 6.7 now. This is the new UI. If you want to go back to the old UI, we can. Just go here to Classic, and it'll look like the old UI. This became the default UI as of 6.6 or 6.5, I believe. But all the stuff is still the same. So policies are configuration sets that get pushed down to the box, right? You want to configure a firewall policy, you want to configure the firewall, you go to the access control policy. You want to configure an IPS, you go to that intrusion policy. You want to scan for malware, configure the malware settings. You go to the malware policy, okay? So these are just sets of configuration that are then pushed down to an actual firewall from the manager. Does that make sense?
Yeah, so if you're in an environment where something that would normally be considered malicious by the engine is something that is a typical experience, you would want that skipped over.
Yeah, so the engines are able to determine when they should kick in and when they should not, right? So for example, if I'm sending packets through the firewall, but none of those packets are part of a file, well, then the file policy won't kick in for that particular flow, right? So the way it works, and stop me if this is review, guys. I want to make sure this is a good use of your time. So far, is this helpful? Is this resonating?
Yeah.
I get a yes from Charlie. Anybody else?
Yes.
Yeah, it's all good.
All right. Robert, Mo, you guys keep and Jason, keep an ear on the chat or text and let me know if I'm veering off into places people don't care about.
Will
I'll
do.
do that.
So I have these policies here, and I have to, first let's do this. Let's go to devices. So to manage the devices, I go to the devices tab, and here I have all my firewalls. In this case, I only have two firewalls. I have two 2130s and an HA pair, okay? And you can see here the HA pair has assigned to it an access control policy called default ACP. That's the name of the access control policy assigned to my firewalls. Now, I thought I just got done saying that policies are where you configure everything, right? But here it's only showing one policy of firewall policies assigned to these things. So what about all this other stuff? Well, that's the thing about firepower is all these other policies, intrusion, malware, DNS, pre-filter, it's all glued to the access control policy. And then that access control policy is what you assign to a particular box. Okay? So everything gets tacked onto the ACP, and then that is what gets pushed out as the config for that firewall. Right? Now, you can set up, rule-based access on firepower. You can say, I want this kind of user to only be able to look at intrusion events, or this kind of user to only be able to configure firewall stuff and nothing else. So that all that still applies, but at the end of the day, everything gets glued to a single access control policy, and that's what gets pushed out to the firewall itself. Okay, so to that end, it's kind of an important thing to manage. So let's take a look at mine. Now, before I dive into this, let's go back to our diagram here. You notice here, this right here is your L7 ACL, right? I guess that could be thought of as the access control policy. Down here is your L3, L4 ACL. Over here, your snort rules. Over here is your malware policy. Over here is your network discovery. Nowhere here does it say strictly access control policy, right? So the reason I'm pointing this out is because when you configure the access control policy, it puts those individual configurations into their proper place along this packet walk. Right, so it does all that for you. So there's not just one place that you can go, oh, that's the access control policy, right? That doesn't exist. That's just a construct for you to visualize how traffic you want to have traffic go through the box. So one thing that you will see here is right down here. I have this pre-filter policy thing. Hey Siri, shut up. Sorry. You'll notice right here that one of the first things it hits is the pre-filter policy. That is actually a policy that is not part of the access control, right? You see right here, I have a default pre-filter policy tied to this default access control policy. The reason we have this, even though we list it here at the bottom in the menu system, this is actually the first thing that gets touched by the firewall engine. That's because, technically, we have two firewalls, I guess you could call it three firewalls, inside of our firewall. We have the pre-filter policy, which basically is just an L3, L4 ACL. Right? So just your old school ASA firewall idea, that's what that is. Okay? We then, all the way up here in the snort engine, have the L7 firewall engine. That's where it's analyzing the packets to see what kind of application it is and denying people access to Facebook because you don't like them. Okay?
Hey,
So
Mark?
The
Yeah.
people or Facebook?
Depends on your point of view, I guess.
There was a question in the chat. Someone had asked, what is the difference between the FM 162646 and the virtual appliance?
FM 2646.
It says 16/26/46 -00 and the virtual appliance. Or Ray, if you want to come off mute and ask your question, in case I'm not reading that or interpreting that correctly.
Yeah, Ray, can you clarify?
I guess there's a 1626 4600 series, right? There are three sets of appliances and the virtual appliance. I see there's a virtual appliance.
Yeah. Yeah. So you're talking about the managers.
Right.
Yeah. So we have, just like the firewalls, we have different models of firewalls for different throughput. We also have different versions of managers, and they just have larger capacity stores and more CPUs to process and manage more firewalls than the lower models, right? So the 1600 FMC appliance can only manage, I want to say, 150 firewalls, whereas the 4600 can do, I think we're up to 300, maybe 500 now. right? Yeah. And then we have the virtual versions of that as well. So if you don't want to run it in hardware, you can run it in VM. There's the FMC 300V. That's a virtual management center that can manage 300 firewalls. Did that answer your question, Ray?
Yes, it does. What about the virtual appliance?
Say that again.
The virtual appliance. How many firewalls can you manage with that? Is it unlimited or?
There's two main versions. Technically, there's four, but there's two main versions you would want to stick with. The original virtual appliance could only manage 25 appliances. We just recently came out with a FMC V300 version, and that will manage 300 appliances, and it is also a virtual machine. There's two levels, and no, you cannot upgrade from one to the other. Sorry. Did I hit your question?
Yes, it is.
Good question. Anything else? I saw a chat pop up for a brief second here. So it's like service profiles that groups different policies into a policy set. Exactly. That's exactly right. Where we have everything kind of tied to this policy set. In our case, we call the policy set an access control policy. And then that is what gets pushed down and assigned to that particular device. There can only be one access control policy per individual firewall, right? But that access control policy might have tied to it multiple IPS policies, and it might have multiple malware policies, right? So you can kind of get tricky that way. You can also nest policies inside of each other. So you can have a global access control policy, and then underneath that, as a subset, you can have a branch access control policy. And then that gets merged into a single policy and pushed out. The reason you may want to do that is you may have multiple managers of your firewall policies, and you may have a global corporate policy that you have to adhere to everywhere. So you put that in the global policy, and then in the nested policy, the individual branch managers can make those decisions if you needed to do that. So this pre-filter policy is essentially the old school ASA firewall. That's pretty much what it is. In fact, if we go over to it, even though it's down here at the bottom of the list, it's the first thing the packets touch. So I come in here, I'm going to click on this policy down here. And you can see here from a firewall rule perspective, it's pretty sparse, right? I can do interface objects. I can assign this firewall rule to. I can assign a network object to that. These are just your IPv4, IPv6 objects. I can assign VLANs and ports, and that's it. And then the actions are pretty straightforward. Block, analyze, or fast path. Okay, well, block drops the traffic on the floor, right? It blocks it. Analyze sends it down this decision tree and up into the snort engine here to be further analyzed, hence the name, right? Whereas fast path is the third option. Fast path is really fun because believe it or not, all of this L3, L4 processing, it happens in the NIC itself. It doesn't leave the NIC. It stays in that network interface, that jack you plug it into. It stays in the circuitry of the jack, and that's where we keep all the state for all the stuff. And so by selecting the option of fast path, we basically bypass all this and send it out to its destination. So we skip over the snort instance altogether, all the snort engines that we have, and send it back out its destination NIC. So all of the routing, all of the L2, L3, L4 stuff, that all happens in the NIC circuitry itself, meaning it's very, very fast. hence the name FastPath. So why would you want to do that? Why wouldn't you just send everything through the same firewall engine and be done with it? What advantage do you think we could glean by having this shortcut option through the firewall?
Can probably offload a chunk of processing so that it doesn't have to go through the full evaluation.
Exactly, right? We decrease latency. Now, what kind of traffic doesn't like latency very much?
Voice.
Voice, right? RTP, that kind of stuff. Okay, so we can make it different. We can understand the difference between a setup call and the actual UDP traffic that actually houses the voice packets, right? We can make the distinction there. So that's what FastPath is. FastPath is designed for you to say, look, this is my voice subnet. Nothing on here is ever going to be on here except voice. FastPath that sucker. Now, some of you may not be a question. Or not. Okay. So some of you may not have the luxury of having a dedicated voice subnet, right? So to that end, in our L7 firewall engine up here, right? We've now sent the initial packet through all these engines up the DAC. This is the dynamic access queue. That's what that stands for. It's just how we line up packets to an individual core of the firewall, so these things can all happen to it. Once we get here, these are the actions we have from an L7 point of view. Allow, trust, monitor, and then all the fun blocks. Okay? So allow is just that. It'll let it go through the firewall engine and then be passed out the ASA side onto its destination. Whereas trust means keep the traffic that I've analyzed here in the NIC. Basically, kick it down to the fast path. Don't scan it with Snort. Don't scan it with Advanced Malware Engine. Just get it out as fast as possible. So you could have a rule like this where you come in here and you look for apps and you could do, VoIP or voice. That might be better. Okay, and you can define your voice traffic via an application filter and then kick it down to the NIC again. So the engine is smart enough to say, oh, look, this is a trust action. I know what it is. All subsequent flows or all subsequent packets that match this flow, just fast path it, keep it in the NIC. How am I doing so far? Am I too deep in the weeds here? Is this making sense to everybody?
So far, so good.
Okay.
Yeah.
Good deal. Okay, so now we are past the L3, L4, the pre-filter. So that's what the pre-filter policy is for, right? So now you'll notice if we go through this again, keep going through this, we have this SI decision block here. This is our security intelligence system. This is one of the big things that Talos can help you with. Now, if I go to my access control policy, you'll see here the first tab is rules. These are your firewall rules. The second tab is your security intelligence stuff. This is where Talos steps in and says, look, we look at the whole internet. We know the things that are bad and we know the things that are good. We're going to tell you about all the bad crap that we found and you can just block it. Now, why do you think we put the security intelligence before the L7 firewall?
I would imagine a lot of it can probably be identified before you have to go that deep into the packet.
Exactly, right? The L7 firewall has to look at the packet, has to look at the individual ones and zeros inside the packet, match it to a signature, and then make a determination based on what app we can tie it to, right? The security intelligence, it's looking at IPs, domains, and URLs. Typically, that stuff is not encrypted. So we don't have to go too deep in the packet to find it. So here, I'm just going to go down to my objects down here at the bottom, and all these objects here, starting with attackers, all the way down to Tor exit nodes, they come from Talos. These are, for example, if I mouse over this.
Would DNS be in there too?
Yep, I'll get there. I'll show you that one. So my attackers match 517 IPs that we know are tied to bad guys. Crypto mining, 1,159 IPs are tied to that. Command and control, 4,883 IPs. These are just IPs, right? So I just take all of these things that come from Talos. Tor exit nodes, 1,140 Tor exit nodes. I just add all of these to my blacklist. So whenever we see this, we just drop it outright. If I see any of those IPs, they just get automatically dropped. You don't have to process the packets any further. Same thing on the URL side, right? URLs that are tied to attackers, crypto mining. There are 76,448 URLs that Talos knows is tied to crypto mining. Whenever we see any of those, we're just going to drop them. Command and control, 470,166 URLs. Okay, almost 500,000. And just by doing this and adding it to this drop list here, I am stopping that traffic from coming in or calling home.
So now, would all of those URLs tie to those IPs that you had mentioned before?
Sometimes the matching between URLs and IPs is a little dodgy because they jump around so often. But by and large, yes.
Okay, because the IP numbers seemed to me.
Well, you can have multiple URLs tied to the same IP, though, right?
Right.
So even though there's 500,000 command and control URLs, that might only be a handful of actual physical IPs, right? Same thing with domains. Now, domains, they get their own category because we can do a lot more with domains. So that's what this DNS policy is here, right? Is doing right here, right? With the DNS policies, same idea. You can add a DNS rule, and then you can reply with domain not found, drop, or my favorite one, sinkhole. That one's really cool. But then you can apply it to certain networks and whatnot, but essentially same idea. You go to the DNS tab, and these are all the domains coming from Talos tied to those particular objects. There are, again, 462,506 DNS domains tied to command and control. So I just block all of them. Now, here on the DNS policy, we have a few more options than just drop or allow. My favorite one is sinkhole. Okay, typically what would happen? Sorry, I was yelling. Is Firepower would see a domain that it knew was bad, try to call home, or it would see a DNS request, I should say. It would see a DNS request, try to go to resolve a domain that it knew was bad. Okay, so we're just talking at the DNS layer right now. We're not talking actually passing traffic, right? So the scenario is someone inside the network is infected. That malware makes a DNS query for the domain it's trying to call home to for command and control purposes, right? So it goes through the normal DNS stack, right? Or it has hard-coded DNS and tries to call out directly to Google's 8.8.8.8. Either way, the firewall is going to see that DNS request for a domain it knows is bad, and it would drop it. So the malware would just sit there going, oh, I can't call home, man. So what we introduced here was the problem with that was you didn't really know where the bad DNS request was coming from. So you couldn't target the host that was infected, right? Because they would query your internal DNS server. It would go, I don't know, and it would then send the DNS request out to the internet to get resolved. At that point, the firewall would step in and block it. So you know someone's requesting a bad domain. You just don't know who, because it's going through your DNS server. Does that make sense so far?
Yeah.
Yes.
So what Sinkhole does is instead of saying, you can't talk to this domain, the firewall says, that's me, right? And so the malware gets a response back saying, oh, that's this IP? Cool. And it dials home directly to the firewall or to a honeypot that's beyond the firewall or that doesn't even exist. So the firewall can then pinpoint exactly who that person is that's asking for that malicious stuff. Okay, so that's what sinkholing is. That's really a fun feature. Lets you target, zero in on who those bad guys are. Okay, so now finally, we're at the access control policy, right? So we stepped through all this. We did the pre-filter stuff. We did the security intelligence. That's what SI stands for. SSL decryption can happen in between there, and there's a policy dedicated just for that. This is all about when you should decrypt and when you should not decrypt. That's all it really is. If you can afford to, do not do it on the firewall. Okay? Because even though we have hardware accelerators in the firewall for SSL decryption and TLS decryption, it's still very expensive on the CPU. And the box throughput drops significantly when we enable SSL decryption. Now, if you have a box that can... Go ahead.
If you're not doing it there, where would you do it?
Ideally, you would want to do it on a separate appliance before the firewall. Like a Radware appliance or an A10 appliance. They're relatively inexpensive up to a certain level. I know the Radware ones are pretty cheap for a basic box that does 6 gigs of decryption at wire rate, which is way more than a firewall could ever do, right? And then hand it off to the firewall unencrypted. That's just the most ideal scenario. But if you have a box that can do, say, a gig of decryption just fine, and you're only putting it on a link that only does 250 megs, then you're probably okay. But any of the bigger stuff, like anything beyond a gig requirement of decryption, you're kind of getting into, the balancing act of, do I buy a giant firewall just to decrypt, or do I get a relatively modestly cost decryption appliance and get a normal sized firewall? Okay, so now finally we have the access control policy, and this is where all the fun stuff happens inside the box, in my opinion. Well, this and the IPS policy are the two fun parts. Everyone has probably seen this before, so I'm going to walk through it relatively quick. This is a zone-based firewall now. Okay, we can tie it to interfaces, but it's mainly a zone-based firewall. And my destination is inside, source is outside. So you assign zones for the traffic flow. We'll call this block bad apps. Okay. And source, actually, let's flip this. We're just going to say the source is going to be inside destination any, right? And then my action here is allow, which would send it through the firewall engine, but then send it to the snort engine to be inspected by the IPS, and potentially the malware engine to be inspected by the malware part, right? Allow, what does allow do?
Permit.
Fast
path.
Right. It sends it back down to the NIC and out. It bypasses the IPS and everything, right? Monitors, that simply lets the three-way handshake occur so we can see what's happening, and then sends it down the firewall list again to find another match. And then we have all the blocks, right? Block with reset. I call that polite block. And then there's the interactive block, which is how you educate your end users that they're stupid.
Don't go here.
Right? So this will pop up a web page to the end user if it's a web application, said, hey, moron, what you're doing is not necessarily allowed. You want to still continue? And they're going to click yes, and they would let them through the firewall at that point for that particular traffic flow. I don't have a whole lot of customers that use it, but some do like it because it helps with the education of, hey, you're on company time. Don't go to Facebook if you're not part of marketing, kind of thing, right?
Okay, we've got plenty of industries in the LA area where you've got egos and folks that are paying the bills for these things that you don't want to necessarily shut them down.
Yeah, and you have a separate category for the people that hold the purse strings, so those rules don't apply to them, right?
True.
So then we have our networks. These are your IPv4, IPv6 networks. Now, one thing I like to show off here is I'm in the middle of creating a firewall rule, right? What if the object I want doesn't exist? Well, that's what this little plus button is for. I can click plus, add an object, and now I can choose what kind of object I want it to be. A host, a range, a network, FQDN. Let's say I want to call this my internal network. And how many of you guys have more than one firewall in your environment? Or more than one location, physical location?
Here.
We do.
Okay. So are your inside subnets the same on at both of those sites?
No.
Probably not, right? They probably have separate subnets, even though they're 10 dots or 192s or whatever.
Yeah,
So-
they're separate VLANs.
Okay.
Oh.
So what we can do here, and this idea of object override is what I'm getting at here. This allows me to say, I don't know, we'll do this 10.10.10.0/24 is going to be my default value for this object called internal net. But I could come in here and say and override it. And I could say for this firewall, I want it to be a little bit different. I want it to be 10.10.11 instead of 10.10.10. So they'll save that. And so now, whenever I use this object on any firewall, it will equal this, except on this firewall. It will be changed to be that. So it becomes locally significant. This means you can have the same firewall policy with the same objects defining policy pushed out to multiple firewalls, even though the subnets or the VLANs or whatever else don't exactly match between the two sites. Meaning you can have one policy managing multiple firewalls all at once. That makes sense?
Yeah.
I really, really like that feature. And that's applied everywhere we can. Subnets, hosts, FQDNs, VLANs even, right? So all that, you can have a voice VLAN that's overridden. So you could say in New York, my voice VLAN is 101. In LA, my voice VLAN is 201. And it would still work the same across both the systems. VLANs, users. So users, this is tied to Active Directory. You can ignore the zones and networks and VLANs if you know your users. So this integrates with the Identity Services Engine, where we can say, if Bob from accounting tries to go to Facebook, then block Bob. But if the CEO tries to go to Facebook, allow him to do that. So this is where you could bring in that user data and ignore VLANs and subnets and IP addresses. The all-important applications. Now, the way applications work, it's a signature-based system. That's how all application recognition works, no matter what vendor you're using. It's signatures. So Talos writes all of these. So in my rule here, we're creating a rule that says block bad apps. So I can painstakingly go through here one by one and enumerate them by hand. Right? So these are all the Facebook apps. Or I can look at these categorically, and I want to say I want to look at apps that Talos considers to be high risk and low business relevance. And then boom, there's 102 of those that match that description. In fact, there's some fun ones in here. There's BitTorrent, eDonkey. My personal favorite from back in the day, where'd it go? There it is. LimeWire. You guys remember LimeWire? Morpheus,
Wow.
right?
What is
So
that?
these are, MySpace is now part of that category, by the way. These are all there now.
That's going back a
Right?
ways.
These are all there. So I'm just going to add this whole category to my rule here.
I think Thelma had a question or a comment.
Yeah, please.
What is LimeWire?
It was a peer-to-peer sharing application like Napster,
Oh,
but it was mainly used for sharing of apps.
okay.
like-
I don't know Napster, but I know peer-to-peer. Never mind. Okay.
Yeah.
It's got to be well over 10 years old.
No, more than that. Yeah.
That was back in the early 2000s.
Yeah.
Then you have your ports, which again also support object override. So you can have a port for voice, and it can mean different things in different locales if you wanted. URLs. So we have URL categorizations here. So I could look at, for example, financial. I could look at finance, and then I could. We have a reputation system built into this as well. So if I did this, I'm going to do an interactive block now on any financial system that is less than trusted. Now, if I change this action from interactive block to allow, this changes, meaning I'm allowing favorable and trusted. So this is smart enough to know what you mean when you based on what action you select. So this is all the firewall stuff. This is just how we're matching the packet flow to then do something. In this case, the something we're going to do is an interactive block, right? Now, because this has the potential to go through the box, because they could click on that "I want to be a moron" button and access the data, this is where we have the IPS step in. So after the firewall's done its thing, we then assign what kind of deep packet inspections we want to do to this particular traffic pattern that we've defined here in the firewall table itself. In this case, I want to scan it with an IPS. Now, these IPS signature lists that I'm showcasing here, these are just subsets of the 40,000 IPS signatures we have in the system. These are just subsets of those with more turned on than others, right? So maximum detection has, I think, like 30,000 or 35,000 IPS rules turned on. Never do that one unless you're actively under attack, okay? Because the box will slow way down. Connectivity over security means it favors connectivity over the security aspect of the traffic flow. So there's a lot less signatures turned on in this one than in security over connectivity. Or you have a custom one that I've built here, okay? The variable set, this is how the IPS policy knows what to base its pattern off of. I'll get to that here in a second. And then the file policy. If there's any files, how do you want to scan those files? We then have the logging, right? So you always want to log at some point. I typically log at the end of the connection. And if I have this box down here checked that says event viewer, that means the log of any time that firewall rule is matched will be sent to the Firepower Management Center. I could also send it to a syslog by checking this box if I wanted to, a syslog server. Or I could ignore sending it to the Firepower Management Center and only send it to the syslog. So it's up to you. You got limited storage space on the FMC. The bigger boxes have bigger storage capacities because they're managing more firewalls. So your retention time on the larger appliances, larger managers, may be a lot longer than on the smaller managers. But that's kind of how the firewall rules work. Question?
Yeah, I have a question. We're at a point where I think we want to change the current settings to the IPS that's within our firepower. And is there any kind of like can we just, before we make any changes to even higher levels of packet inspections and signatures and behaviors and whatever it looks at for, can we try it out first by just having it go into audit mode or anything like that? Does it have any kind of modalities? So if we change the whatever levels that we have right now to something higher, can we just try it out like in an audit kind of way?
Sure, of course. Good question. So here I'm going to modify one of the IPS policy that I have. I'll show you how to do that here. So this is this is based off the Snort engine itself. Okay, the Snort engine and very soon the Snort 3 engine. Right now, this is running Snort 2, is what powers all of this. And so what we're doing is we're reassembling the packets into their normalized form, scanning them for specific pattern matches based on which signatures we turn on, and then dropping or allowing the traffic. So you have to enable the signatures you want to look for because you can't turn them all on at once. So to your question, how do you turn on a signature without accidentally breaking stuff, right?
Yep.
So here in my policy, I have 8,820 rules turned on. Firepower actually recommends I have 11,000. I should have 1,123 rules turned on for sure. I'll talk about that here in a second. But these rules are all housed right here. Okay, so here's all the rules. 45,000 IPS rules. Okay, you can sort through them here fairly quickly. You want to look for Heartbleed. You guys remember Heartbleed?
Yeah,
Yep.
I remember.
Okay.
Yeah.
Here's all the signatures that stop Heartbleed. So when your boss says, "Are we safe against this attack?" Yes, you are. Right? You could also look at these things categorically if you wanted to. So if you want to look at, for example, I don't know, problems with Internet Explorer. Well, there's that category of rules. So these are just fancy filters. It's all these things here on the left are. Or if you want to look at Microsoft's vulnerability numbers, right? You can pop that on, and then it'll show you the signatures you need for those particular Microsoft vulnerabilities. So MS0745, these are the signatures you have to turn on to stop those attacks until you can get patched, right? If you go to rule content, we have a few more filters that we could look through. For example, if you know the CV, everyone familiar with CVE, common vulnerabilities and exposures?
Yeah,
Yes.
absolutely.
So you can pop those numbers in here, and it'll show you all the signatures that match the CVE. So we try to make it easy to sift through the ones you want to get to. So once you have the rules you want, you have this idea of policy layers. So I've based my policy set, my IPS policy set, off of the Talos recommended balanced policy. I then have the my changes layer. And in between this, if I wanted to, I could have a firepower recommendations layer where firepower will automatically discover what you have in your environment and then recommend to you which signatures to turn on based on what it sees, which is really nice. It's like an auto-tuning IPS, like a Nest thermostat learns how you like your temperature. This is the same thing, but with your security, right? Where it learns, oh, he has a bunch of Windows 7s in his environment, so I'll probably turn on the Windows 7 rule set.
Quick question for you.
Yeah.
So instead of like, I guess using Talos and some predefined like rules or policies that you have there, do you guys have like a sandbox where it's allowed to go in and you inspect that, or whatever you inspect it, and then you determine whether to process or reject?
Yes, we do. That's on the file side, though. We're talking strictly about the packets here is what we're looking at right now.
Okay.
Yeah. So we make a distinction between packet-based attacks and file-based attacks, and they're two different things, right? Because you could pass a piece of malware through an IPS engine, and it won't see it as malware because the packets themselves are not misshapen or misused in any way. It's just when you reassemble those packets, they become malware. And that's not what an IPS looks for, right? Strictly speaking, right? Ours is both an IPS engine and an advanced malware engine in one box. So what we're doing is after it goes through the IPS, we reassemble the packets into a file, and then we check the file. And that's where we send it off to the sandbox to check if it's malicious or not.
Got it. Thanks.
Good question. So to answer your question earlier, Ying, I apologize if I butchered your name there. you can add a layer. And then the test layer, you configure those rules to only monitor traffic, not strictly to drop traffic. So in essence, what you're doing is you're inserting an audit layer on top of your in-production policy layer, and you're not affecting it in any way. But you still get the alerts of what would have fired if it was enabled. So you create a test layer or a pre-staging layer, and then you just say, don't, you put all the rules in here into monitor mode. That make sense?
Yeah, it does.
So one thing that's fun to do, go ahead.
That's what I was looking for. Thank you.
Great. Yep. Happy to help. So one thing that you can do is you can have Firepower recommend to you which rule sets you need. Robert, I know I'm going over time, buddy, so you let me know if I should keep going or not.
8 is not a hard stop. I mean, if the team here has questions, I think we just keep going. Let's check it at 8:15. Yep.
So here, what we've done is Firepower has seen in my very robust network here, the 12 things I have in my environment. And based on what those 12 things are, it's recommending I make 1,123 changes. It wants me to set 352 rules to monitor and 771 rules to drop and generate. Now, I could update the recommendations here. And then based on my network traffic, it will then change what it recommends me to do. But this can be scheduled. Okay, so what I have this set to do is it will twice a month, in my case, scan my network for any changes. Well, it's constantly scanning the network, but twice a month it'll say, at this point in time, this is what we've seen. Therefore, you should probably turn on these signatures because this thing showed up, this thing went away, and it's dynamic in that nature. Now, if any of you have a third-party vulnerability scanning system like Nessus or Tenable or something like that, you can point those results at Firepower. And then Firepower will make the recommendations based off of those results instead of the passive analysis that it does by default, which is really kind of cool because now your recommendations can be spot on. So in my case here, leave. I have, it's made a network map of the things in my environment. Like I said, I have 12 IPs. I can click on some of these and it'll tell me what kind of device it thinks it is. Okay, in this case here, it thinks this is a VMware appliance. And it sees that VMware appliance is housing a number of different things. Red Hat, CentOS, Google, Android, Chromium, Ubuntu, Red Hat. There's probably some Windows in here as well. And now it's going to recommend to me based on what version it kind of thinks it is, because it can't get too granular, because again, we're just passively analyzing data as it comes through the firewall. That I have 157 potential vulnerabilities based on the version numbers of the OSs it thinks I have. Does that make sense?
Yeah.
So if you have a vulnerability scanner, that's going to be a lot more granular from the analysis point of view that it can do. And then you point that result at Firepower, these recommendations become spot on, which makes the IPS a self-tuning IPS based on your latest vulnerability scan, which is really, really cool.
there a
Okay.
particular protocol that it uses for passing that data back and forth or over to it?
We have a connector that or a listener that we spin up, and it via API calls, it sends that stuff over.
Got it.
Yeah. Now, one thing I want to make sure that we talk about here is, oops, sorry, my bad. On the IPS side, we need to tell the IPS what is inside and what is outside our network. And that's where the variable set comes in. This is probably the most important thing you could do on your firewall to make it efficient, is tune your variable set. So I've gone in here to the objects and gone to the variable set, and I'm just modifying the default variable set. By default, the home net variable is set to any. That should change. You need to change this home net variable to be the IP addresses that you own, both internal and external. Those are still external IP addresses are still considered yours. So technically they're part of your home network. So here in my home net, I've defined all the external IPs that I own, as well as everything RFC 1918. That one thing alone will make your IPS extremely more efficient and increase your visibility on the attack surfaces. Now, by doing those two things, by setting up the default variable set, and the other thing that you can do that's related to that is turn on a network discovery protocol, right? So this is a network discovery policy. This is how we passively analyze the network. And we say, look, discover everything that is inside. Meaning, you remember that host map I showed you a second ago that lists all the things I have in my environment? This is how I get that, by turning on this discovery policy. So turn this on, modify your variable set, and then you can go back here and take advantage of the reason that Gartner calls this a next-gen IPS. On the threats tab here, we have this really cool widget called intrusion events. And then we have these numbers here on the left, right? Think of these like DEFCON levels, okay? DEFCON 4, DEFCON 3, it's kind of alert status. DEFCON 1, the stuff is hitting the fan, somebody go fix it now, okay? So what does that mean? Well, these are called impact flags, meaning how impactful is this IPS attack? Okay? The way we get to this is we see an attack coming in at the packet layer, and we stop it, okay? After we stop it, we then say, where was that thing going? What was it targeting? Was the thing it was targeting vulnerable to that attack? If it was, then we mark that as an impact flag 1, high priority event, meaning a valid attack came in and it targeted a system that would have been owned had we not intervened. That's what impact flag 1 means. A 3, on the other hand, is the opposite side of that. A 3 means a valid attack came in, we stopped it, but it was targeting something on the back end that wasn't ever going to be exploited by that attack anyway. So, meh, right? It's just noise. It's not a false positive. It's just internet noise. So in the example of Heartbleed that we talked about earlier, all of these impact flag 1 attacks that I have on my network right now, they're actually coming from our Qualys engine that's doing pen testing against my box. So it's constantly sending Heartbleed overrun attacks against my internal network to try and see if I'm vulnerable to it. So you'll see here, these are all getting flagged as impact flag 1. We still dropped it every time it happened. I have all the IPs involved in that attack, but I don't have to worry because my IPS is stopping those attacks from getting through. Now, should I go ahead and patch my server on the inside? Well, yeah, ideally I would want to do that. But that's what's going on here, right? If I took the same attack, now I can actually drill down here if I want to all the way to the packet layer and see the actual attack. if I wanted to take this attack and launch it against something that is not running OpenSSL, meaning it's not going to ever be vulnerable to a Heartbleed attack, then it would be considered Impact Flag 3, right? If I try and launch a Heartbleed exploit against your internal iPhone, who freaking cares? I'm never going to get into your iPhone, right? Because it doesn't run OpenSSL. So those are the first two major engines that I like to talk about, is the access control engine and the intrusion engine. The last one would be the malware engine, which is fairly quick. You basically go in and turn it on and say, anything that reassembles all the packets into a file, if that file's malware, drop it. Or if I don't know what it is, send it up to the cloud and analyze it in that sandbox in the cloud that you get by purchasing the system. So the way all those things are tied together, finally, is on the access control policy side. Remember, that's the glue for everything. I come in here, for example, I have this rule right here. Allow outside to my FMC. And this rule is matching source and destination zones. It has specific IPs involved. But finally, I have an inspection rule. This particular rule is going to scan the packets with the security over connectivity IPS policy, and then it's going to scan any files with the advanced malware policy for this one pattern of traffic. Now, I want to be really clear here. Once I have a match on the firewall, this action will take place, and then these two other actions, these subsequent IPS, which is what the shield icon is, and malware, which is what the file icon is here, these two actions will happen after the firewall action occurs, and then the firewall's done with it. The traffic then doesn't keep going down the firewall to find another match. Once we find a match, an action happens and the packet processing stops. Does that make sense?
Yep.
So it's really important to make sure that this is an allow-only rule set, because your default action down here is a block all. Now, if you wanted to turn it into an IPS-only box, you could by coming down here and then selecting an IPS policy. But keep in mind, by doing this, you're not saying scan everything with this IPS policy set, right? You're saying, if it doesn't match any of these rules, then scan it. That's what the default action is designed to be. Okay, so just please keep that in mind. Also, some other tricks real fast. Put as many of your L3 and L4 rules that can't go in the pre-filter set, put them at the top of your access control policy, and then have your L7 rule sets after that, like your application layer rules and those kind of things. They should be near the middle and the bottom of the IP or of the firewall rule table. You also want your most specific rules near the top and your most general rules at the bottom. So, for example, if you had a rule that says, look for this source and this destination with these subnets on these ports and this application, well, that's 4 or 5 things you're matching a traffic pattern to. Put that at the top. If you don't, you're going to get some weird errors. So, for example, if I did this, I drag this rule number 9 up here to the very top, and then I check this box, I'm going to get kind of a weird response. Actually, let me undo that. Let me add a rule real fast. We'll call it a test rule. We're just going to allow all, because I don't want the firewall messing up my app. If I put it at the top here, you notice I checked this box called Show Rule Conflicts. Notice all these rules now have an orange triangle next to it. It says this rule is preempted by rule number 1, meaning none of these are ever going to match, because this rule is always going to match before it gets anywhere else. Does that make sense?
Yeah.
So use this checkbox. This is all staging area. So use this to check your logic before you push out your firewall policies. Then when you're done, you save the changes and then you hit the deploy button. Now, last thing I want to show off before I let you go is we've made some improvements in 6.7 and above on the visibility or the management side, where I can now monitor my devices and see how they're doing in real time. I see my CPU status here with some cool graphs, my throughput rate, my NAT tables, my interface connection status. So this is really handy when you're starting to troubleshoot things. I can look at my snort engines and how they're performing, my connection events, what's going on through there. In 7.0, which is coming out here shortly, this graph mentality will also apply to your FMC. So you'll be able to see a lot of those details with the FMC here as well. But packet tracer is still in here. You can still test your rules using packet tracer before you push it out. So all that's still baked into the system itself. That's all I can kind of rush through, Robert. Anyone have any questions that I didn't answer along this whole spiel? I'm happy to hang out and talk some more if you want.
I had one. It was another one of those idiosyncrasies we hit a few years ago. When bringing the system into a business that didn't have a prior appliance in that space, we ended up having to put initially things in line rather than layer 3. But then also wanted to mix in other subnets on a layer 3 basis subsequent to that, and we're stuck. We couldn't mix and match.
Yeah. So
Is
it
that
used to be
still an
you had
issue?
to choose. It used to be you had to choose between L2 and L3, right? An L2 firewall or an L3 firewall. Today we can technically mix and match that. We have what's called interface bridging, where I can have interfaces on the firewall tied to just an L2 firewall, but then they have a VIP inside the box that then ties it to the L3 firewall.
Okay.
We also have modes that are designed for IPS only deployments, where it's an inline mode where a packet will come in, there's no routing, there's no switching that it gets applied to it, but then I can still go in and apply all the same firewall rules and all the same IPS rules. The only catch is whatever goes in one interface has to go out another dedicated interface that's tied to that other one, right?
Right.
That's more of an IPS deployment mode. We even have, fail to wire modules you can slide in the firewalls. So in an environment where traffic cannot stop, period, if the firewall goes down, if it's in IPS mode, we can utilize those things as well. That'd be more like a layer 1 deployment.
Got it. Okay, cool.
So there's a company that just paid a $5 million ransomware. You probably know who I'm referring to.
Yeah.
In the news lately. I mean, how could we help these guys out? I mean, could we sell them like 50 of these boxes there?
Potentially, the FTD is really good at stopping command and control call home. And typically in command and control or in ransomware, the malware has to dial home to generate an encryption key for that customer. Talos is really good about finding that stuff. So the firewall potentially would have caught that. A better option initially probably would have been to have Umbrella involved, because it has a bigger database than what Firepower does for the command and control domains. So that may have been a better option to stop it. My guess is the malware probably entered the environment via email.
Yep.
And somebody got tricked into
That's not what I'm hearing. Well, what I'm hearing is somehow they have an air gap system, but there's a security guard, and I'm not sure how he did that. He connected to a wireless controller inside the
he bridged
to
the
watch
gap.
his videos, yeah. And somehow like cross bridged or something like that.
That sucks.
Yeah.
Yeah.
I
so,
think the scripts attack was through email.
Where'd you hear that, Thelma?
I'm not gonna say.
That's that's probably what I'm thinking too.
It takes a lot of work to, scan an environment from the outside and, through Nmap or whatever you're gonna do, and listen, see who's listening on these open ports, and try to gather more information. That takes a lot of work and a lot of time. Whereas all you need is an email and you're done. Boom, there's your $5 million.
As soon as you can generate your administrator credentials, right, then you don't even need malware anymore.
Yep.
All right, everyone. It is 8:20. Mark, thank you.
Thanks, Mark.
I think we got a lot of
That was
good
great.
questions.
Yeah, happy to help. There's a lot we didn't cover. If you have any individual questions, I'm happy to answer them for you. The Firepower 7.0 is coming out here shortly with a lot of cool features involved in it, specifically regarding VPN and AnyConnect. That's going to be a real big boon in the 7.0 code. So be on the lookout for that here shortly.
Thanks, Mark. I think Jason needed to drop, but we will get this posted. No PowerPoint this time. I know, again, you're all disappointed, but the recording will be posted so you can go back and replay this as needed. Mark, thank you. So Rob chat about that. We will meet up again next month. Thanks, everyone.
All right.
Thank you all.
Thank you.
Okay. Bye.
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 Thanks a lot, man.